Awesome.
Wherever you're watching this, though, folks, please let us know where you are tuning in from. One of the things we love is every Thursday morning seeing the OpenCV community chime in the comments saying where they are joining us, watching us from. The global community never ceases to amaze us. So, hello, I am, of course, coming to you from beautiful, fragrant Soma in downtown San Francisco, California. And our stalwart host, Dr. Satya Mallick, is joining us from
San Diego, California.
Right.
Yes, please make sure that from the drop-down, you select everyone in the chat section and respond, where you're joining from.
Yeah, on Zoom.
And yeah, that's great because, it gives us a lot of satisfaction when we see people all around the world joining this every week or almost every week. And today we have a great episode. We are going to teach you one concept using computer vision. We'll talk about automatic document scanner. And then we will do the same thing a few weeks later using a deep learning based technique. So it's going to be fun. You'll learn, even if you know approximately how things are done, you will find it interesting, right? The different kinds of techniques we use in this particular tutorial. All right,
a
so
rare,
we have
a rare two-parter. I love that.
right.
Good morning out there, India. We got Vietnam, Central Pennsylvania, United States. Hello, Poland. Of course, looking on our other destinations here. Let's take a look-see. Over on LinkedIn, of course, we've got India, we've got Germany, we've got Boston, Massachusetts, Colorado Springs. Hello, Serbia.
Right, we have people coming in from all over the world.
Love to see it, folks. Love to see it. As I said before, if you're just joining us a little bit later, please let us know where you're joining from in the chat, wherever you're watching, YouTube, Twitch, Facebook, LinkedIn Live, all of the good places on Al Gore's internet. Hello, Michigan. Where in Michigan are you from, Chad? You can't. He's not on video, so the chat can't show me. But we do this. See, the Michiganders can point on their hand. Zealand. Wow, I know Zealand. I believe my brothers had wrestling meets against Zealand in high school. So, hello, Palm Beach. Hello, Colombia. Hello, Toronto. Hello again, Germany. Hello, more India over on YouTube. Ragav on YouTube. Hola. We've got Andy Matthews. Hello, England. Good old England. Hello, Richmond, Virginia. Always a pleasure to see all of you good folks out there in the OpenCV community. We'll get started in just a few seconds here. And here come the AI assistants. We're gonna have to start doing a second contest where people can guess how many chatbots join. So let's see. This week we've got 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh wow,
9. Last week was 10. Y'all are slipping. Hello from Mali. Hello, Mali. Mohammed and Mali.
I mean, these are from the same Otter ones, right? Why don't they?
Yes, it's all Otter AI. I mean, we shouldn't say their name. They should be paying us.
Oh, that's right. Oh, delete.
I'll bleep it. I'll put like some profanity. It'll be like a boop. Hello, Turkey. Hello, Vacaville. Hello, Guinea. Raghav on YouTube would like to know, are we going to see some demos, like some coding and demos, or are you going to mostly be discussing the concepts?
No, demos, I'll show you, I'll give you a Python, the Jupyter notebook as well.
Hell yeah. We've got in the chat, hey, sup bro from Iran. Sup Iran? Hello, California. Hello, India. Hello. Philip says twins, they can account for double. Hello, Spain. Hello, Mali again on YouTube. Everybody loves OpenCV. Let's take a quick viewer count vibe check. On LinkedIn, we've got, it's not telling me here. There's 15 of you watching on the old YouTubes. We got 75 here in Zoom, and on Twitch we've got currently 0. Somebody should get on that. But over on LinkedIn, let's take a quick looky-loo. According to our restream metrics, for some reason, a little inside baseball, for some reason LinkedIn just does not publish like accessible data for their stuff. They really want you locked into the platform, and so to find out how many people are watching your feed, you actually have to go to the LinkedIn website and like open it as a user.
Right.
We've got 25 of you over on LinkedIn, a little bit lower still. They've been kind of messing with us, I think, and splitting us off from a lot of our audience. It seems we have a theory. We're advancing a theory that for some reason LinkedIn kind of has been
Is not liking us?
sequestering. Well, they've been sequestering video streams into like US and rest of world, it seems like. And so a lot of our folks in like India and in China and in Europe and in all sorts of places are just not seeing the stuff on LinkedIn anymore, but all the folks in the US still are. It's kind of a weird situation, but they didn't publish anything about it, so this is just us guessing. They're very secretive about their stuff. Anywho, I think now's probably a good time to get started, Doc.
Yeah, give me 1 second. Let me just get my slides. All right. All right, let me put my slides up. Well, welcome everybody. Welcome to OpenCV Live. And today we are going to present you with the tutorial for automatic document scanner. And we're going to learn a lot. But before we go into the tutorial, I would like to thank Phil Nelson. Phil Nelson is my co-host, and he is the Director of Content and Creative. He's also a doc, Director of Content and Creative at OpenCV, and he publishes this show. He organizes this show. If anything goes wrong, it's his fault. Hi, Phil.
That's absolutely right. Hi, Satya. Thank you so much for that beautiful introduction. I am your co-host with the co-most, the second banana, who is second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you, my dear friends, can call me Phil. And I'm here to remind you of a few things we do on every single episode of OpenCV Live, which is the show that you are currently watching. One of those things is a giveaway to you in the audience. Stay tuned. Later on in the episode, I will be asking a trivia question based on today's presentation. And the first person to answer that trivia question correctly will win the OpenCV course of their choosing from OpenCV University. You can see what courses are on offer at OpenCV University by going to opencv.org/university. OpenCV University is also on YouTube and a bunch of other social media places if you want to follow that learning-specific content. We're also taking questions from you in the audience, and as the late, great Satoru Iwata would have said, we will do our best to answer them directly. Use the Zoom Q&A button at the bottom of the screen or the chat system wherever you are watching, and we'll do our best to answer those questions during the show. If we don't get to your question and it's just have a burning need to know the answer, you can, of course, email us, newsletter@opencv.org. Before we get started properly, though, I think we should talk a little bit about the reason for the season, the Open Source Computer Vision Library. OpenCV is a nonprofit organization that also runs an open source library, and that means that we need your support. One of the ways you can support OpenCV is by buying OpenCV merchandise. We have an official merch store at opencv.myspreadshop.com. T-shirts, pet bandanas, little buttons, those NPR-type tote bags, and of course, the OpenCV standard logo and the I Love OpenCV style in 3 different flavors. We've got English, Simplified Chinese, and Espanol for those of you that speak those languages. I am personally a big fan of the Yo Amo OpenCV shirt. We've also got sponsorships. OpenCV is sponsored by some of the heavy hitters in tech these days, thanks to a lot of work by Satya and a little bit of work by me. We'd like to thank all. Yes, we'd like to thank all of OpenCV's members and partners here. Huge shout out to the more recent ones, such as ARM, we're really excited about the partnership there. Of course, we've got our old friends at Tangram Vision and the Edge and AI and Vision Alliance, Drone Code, Rerun, Big Vision, of course, Satya's joint, and of course our friends at RoboFlow, who will be joining us once again next week. We've also got OpenCV University. Doc, you want to tell us a little bit about University?
Yeah, so OpenCV University is essentially, it's a collection of many different courses, about 6 different courses that prepares you for a journey for your career in AI. So a lot of people say, how is it different from, courses available on Coursera or let's say, Udemy and other places? The thing is that most of those courses are very short courses. You can finish them in 7 days or so. Our courses are laser focused on computer vision, right? Computer vision and deep learning. And we are very hands-on, right? We come from a consulting background, so we use the things that are useful in our consulting work, and we teach those things. So it's very practical. People have learned a lot and gone on to do amazing careers from OpenCV University. The main difference, between us and most of the material out there is that we are laser focused on AI careers, right? We don't want you to just take a 2-hour course and say that you're an AI expert. It takes a good 7-8 months to get through the material. At least two courses would take you about 7-8 months, and that will make you an expert, right? But you have to put in the effort. So that's the philosophy behind OpenCV University. We are training the next generation of AI experts who have depth, right? Not the people who use AI, but the people who create the AI behind all these, the automation or behind all these beautiful applications, right? That's where we want people to be. And you can join OpenCV University. In fact, I'll give you a link to join a webinar that will explain you more about OpenCV University later in this webinar.
Excellent. And, there's, I've said this before to Satya privately, I think, and maybe before on the show, but we're kind of still in the midst of what you could consider an AI gold rush, with all the good and bad that a gold rush comes with it. I'll say this. Historically, the best position to be in during a gold rush is to be the one selling the shovels.
Exactly.
If you can learn how to sell those shovels, you'll be in a good place no matter what happens in the industry. So check out OpenCV University. Really highly rated courses. You can see the crawl of all the different global institutions that have used OpenCV courses and trust them with their educational needs, because again, these are legit courses. These are not something that we're trying to make a quick buck on for a couple hours, like in a weekend, and you call yourself an engineer. That is not what we do here. We're all about legitimate education. So go, please check out OpenCV University, and stay tuned later in the episode so you may win a free OpenCV University course of your choosing. One more thing here before we get started as well. So you can also, individual folks can donate to OpenCV, and we have a new way you can help us. In fact, if you work for a large organization like an Apple or a Meta or whatnot, Microsoft, for example, as well, if your organization does donation matching through Benevity, then you can now find OpenCV, the Open Source Vision Foundation, on Benevity, and many of your workplaces will match donations to nonprofits such as OpenCV. So something to consider as we get later in the year. Those charitable donations, help you have to pay less on your taxes if you're the sort like me that always ends up owing money. So think about that before December 31st this year, and maybe donate to OpenCV, support open source computer vision and AI. Talked a little bit about OpenCV member organizations. If your company benefits greatly from using OpenCV, you should consider becoming a member or advocating to your boss to become a member. We have 3 tiers created for the 3 primary types of companies at various levels of maturity that can support organizations like OpenCV. There's bronze for $6,000 a year, silver for $30,000 a year, and gold for $100,000 a year. These come with a bunch of great perks for our sponsors. And if you are a US-based company, donations to OpenCV are very likely tax deductible within the US. You can also sponsor OpenCV on GitHub. Let's take a look at the OpenCV sponsors on GitHub. We got 10 sponsors over there now. Thank you so much, everybody. I know we're almost doubled, I think, since last time. In fact, RoboFlow is now an OpenCV sponsor. They're double dipping. Those double sweethearts.
That's
big shout out. We'll give them their 5 seconds of fame here. Thank you, Victor. Thank you, Jesus. Thank you, Blue Jay. Thank you. I cannot pronounce this guy's name. Abuzar. Thank you, Nick. Thank you, Ross. Thank you, RoboFlow. Thank you, Marcus. Thank you, Rudis Laboratories. And thank you, DJ Greenwood, Denzel James Greenwood, as well as Marcus Giselin. A teacher in there. Shout out. Big. We really appreciate it. I was surprised too. We were like, oh, wow, we actually have GitHub sponsors. That's all for OpenCV, but a big shout out to our last week. Our guest was Afriz Gan from Mengdang. They just launched their new robot starter kit on Kickstarter this morning. Their goal was 10K US. They blew through that in like an hour. They're up at 13K right now. Super reliable. This is their third Kickstarter campaign. If you're at all interested in these really affordable, fun hobbyist robotics projects, can't recommend them enough. They've got the four-legged mini pupper 2G bot and also the low-cost turtle robot, which does not come with a screen or camera, but does have generative AI capabilities in it. And so they can also talk to ChatGPT, Gemini, Claude, stuff like that. Unlike their previous models, these are assembled. Can you assemble these in like less than an hour, like 15 minutes in some cases, which is pretty cool. So go check them out. Like I said, super reliable. They've done 3 of these campaigns. They have delivered on all of them and with really high marks from everyone that backed them. So check out the new MD Robot Starter Kit, ROS 2 and OpenCV compatible, as well as generative AI stuff on board. OpenCV also has a YouTube channel. You can hit us up on YouTube, and it's also the place where you can find every recorded episode of OpenCV Live. It's youtube.com/@OpenCV official. We're also on Twitch. It's OpenCV_, and we're on LinkedIn. I think we have an Instagram now and probably a TikTok that is I don't spend nearly enough time on. We need some interns, I think. Having said that, I think, Doc, the show is yours.
All right, thank you. Let me share my screen.
You went
So
muted there.
am I?
Oh, okay, you're back. You were silent for a moment. Wow. It was weird.
Really? Okay, I'll have to check my connections. Somebody else also complained about it.
Oh,
all right. So give me a yes in the chat section if you are able to hear my voice clearly and see the screen. And I'll ask you several questions. All right, we see a bunch of yeses. Let's go. All right. So okay,
LFG.
so I'm going to this material comes from OpenCV University, and as Phil has already mentioned, we have a bunch of career paths in AI that you can enroll in. But I'll give you more details later on in this webinar on how to go about it. But first, let's talk about the problem that we are going to solve today. We are going to talk about automatic document scanner. And here the problem is that you have a document or a page of known aspect ratio. You place it on a surface and you take a picture of it and you want to align it. You want to rectify it and align it to a standard format, right? And the question is, why is this kind of application useful? You might have done, you might have, taken photos of your checks or your document, etc. This alignment is necessary so that people can figure out what exactly is there in every cell, right? For aesthetic reasons also, sometimes when you're scanning a document, you may want to put it in this right aspect ratio so that you can create an entire book out of it. So we are going to discuss 2 different methods for it. The first one is a pure computer vision OpenCV based method, which we are going to discuss today. And the second one will be a deep learning based method, which we will discuss on September 26th. The hope is that you're going to learn a lot during this. It's not just this particular application, but we are going to use techniques inside this while building this application, which will help you in other ways as well. Just to focus on the thought process, right, that goes into building an application like this. And today we are going to present you with a sort of suboptimal version, the kinds of things that you could use 5 years back or maybe 7 years back. But today the techniques have evolved and the deep learning version would be taught later on. The reason the computer vision version is still very, very relevant is because of the pieces, right? The pieces that make up this application. You may be able to use those pieces in your own application. And the computer vision version also doesn't rely on any training, right? So there is no data that you need to collect, whereas the deep learning version, you have to collect data and create this. So doesn't
that also, so just another thing here from the chat, some folks were asking that there's, you could say maybe that like the classical computer vision version is a little more brittle in terms of what it's looking for.
Yeah. It is more brittle, but it is great for industrial applications, right? So for example, you could have an industrial application where the lighting is very, constant, or at
Consistent.
least, controllable. The camera is under control. A lot of things are under control, but the data itself may be changing very quickly. I'll give you an example of, let's say you have an inspection task, and let's say you're creating, different kinds of, I don't know, vaccines or something, vials of vaccines, right? And these, some of them would break, right? But let's say you have, every batch is small, right? Let's say you create a batch of 100 at a time, and you just don't have enough data coming in for creating that kind of application, right? You don't have enough data because your data keeps changing. So today you're doing one kind of vaccine, tomorrow you're doing tablets, third day you're doing something else, but you want to do defect analysis. In that case, it becomes very difficult to train a model. And sometimes you may want to do computer vision based methods where it's based on heuristics, it's based on non-trained application, right? So today we are going to learn about morphological operations, a little bit about edge detection, contour detection, homography, GrabCut, and perspective transform. All these techniques will be necessary for you to build this application. And some of these things will go away when we do the deep learning based application. Some of them will still remain, right? You still have to calculate the homography and things like that. So we'll go over it step by step. If you don't understand any of these, that's fine. We'll go over the techniques, right? So the first operation is morphological operation, right? So given an image, if you want to remove all the text from this white over black kind of image, in that case, you could use some morphological operations called opening and closing, right? In opening, you basically have a kernel which removes the black regions, and in closing, you fill up that region, right? And let me show you an example here. So we have this. Let me see if I can share this Colab link. Share. Copy. Anyone can view. All right, so we can copy the link, and I'm going to share it right here. And we'll also share it with the newsletter.
You bet.
Okay. So you can use this, you can use this as what is happening now?
Good old Google UI. Material design, baby.
All right. Okay, so for this, first we need to, download or install NumPy, Matplotlib, and OpenCV. And in Google Colab, most of these things are already there, so you don't have to worry about it. But this application requires only these three libraries. NumPy is basically a matrix library where it allows you to do all kinds of matrix operations very efficiently. Matplotlib is a plotting library, and OpenCV is the biggest computer vision library in the world. All right. So here is a Dropbox link, which we have put all the different test sets, etc., in this Dropbox link. And when you run this, you will be able to get this all these documents inside that folder. And then you go and go inside the document the directory that is produced, right? So that is standard. And when you read this image, you will see this image. It looks something like this. And you'll see that, the only requirement here is that we have made the background. This is a black and white, or mostly black and white paper. And the background could be anything arbitrary, right? There are no restrictions on the background. The only thing we assume is that it is a paper, right? White paper with some black text, which we are going to remove also, right? I mean, it's not a very strict requirement. In the next episode, right, we will not have any of these requirements because it would be a learning-based technique. You could pretty much do anything, okay? So first we have some restrictions on the size so that it doesn't become very large. So we resize the image just so that the processing is done in a fixed amount of time. Again, these limitations are we don't have these kinds of limitations when we build practical applications. But when you're doing a tutorial, you just want to make sure that people don't run into we don't want to put in the logic which is necessary for real world applications, but it becomes cumbersome just trying to explain a whole bunch of code which does solve some corner cases, right? That is why we are just asking you to, we are just resizing the image to this specific dimension, okay? Then we have something called a morphological operation, right? So this morphological operation, as I said, that it works on binary images. It takes a binary image and you can do operations, different kinds of morphological operations. So in a morphological operation, you usually have an image and you have
for those of you that were born in the 80s and grew up in the 90s, you could say it's morphin time.
Right. So there are three required inputs, right? First of all, we need to have the source image, right? And then we need to have the operation that we want to do. There are a few different kinds of morphological operations. The most common ones that people use are erosion and dilation. Let's say you have a binary image and you want to, and a binary image, let's say black image, and you have white text on it, you want to make the text fatter, right, in all dimensions, then you would use a morphological kernel, which is let's say like a circle, and run it on it. And this would make all the text, appear dilated inside that image, right? And then you also have something called erosion, where the text would become smaller. You could erode using this kernel, right? And these, when we teach these things in our courses, because we have a lot of time, all the details, right? We go into great detail into how these operations work, and you will know inside out how these operations work. Now, you can also imagine that you can have an operation in which you first erode the image, right, a lot. So that, let's say you have white text on black background, you erode it a lot, which means that all the text will be gone because it is in white and you're eroding. And then you dilate it, right? So whatever is left, you may be eroding into other structures also, which are very, very large. But when you dilate it, the large structures come back, but the smaller structures will not come back, right? So you can clean up noise using these techniques also in a binary image, okay? So that's morphological, operations. And as I said, that you can go and check out these various in OpenCV doc, what are the various types of morphological operations available. You have erode, dilate, open, close, and so on and so forth, right? So, so here we take a kernel. You can see that the kernel is essentially a 5x5 matrix, right, of ones. So it is all white inside. And here we are saying that we are going to use morphological close operation. And if you think about it, right, and I'll let this thing be your exercise once you get this notebook, figure out why closing actually removes all the text, right? Think about it and then experiment with it, and you'll figure out why the closing operation removes all the text. And you can see that the rest is also a little bit blurry, right? But the edges have not really been affected mostly, right? We just wanted to make sure that the inside is not cluttered, right? And again, this is not always a necessary step, but sometimes, to make the process more robust, you have to do these techniques, right? So here we have removed all the text so that it is very cleanly, the inside and outside, it is very clean. We know that, okay, this operation, when you run this close operation, it is able to remove all the text from this, right? Like magic. Okay, so next, okay, we have removed this.
It's invisible ink, obviously.
Right, right. so that the next step becomes easier, okay? So the next step is called GrabCut. Now, GrabCut was revolutionary for its time. When it came out, we were shocked how well it worked. And here's a little detail. This was patented by Microsoft. And for some reason, it was implemented in OpenCV and nobody ever asked, now the patent has expired, but back then,
That's
nobody
awesome.
asked. Yeah, nobody asked, how it slipped into Microsoft, into OpenCV, but Microsoft never complained, right? So it is in the main library. It is a segmentation technique, right? It is a segmentation technique which works with many different kinds of inputs. So in
OpenCV version 2.1 for the folks listening out there. It's a while ago.
right, it was. I mean, I used it a long time back. So it requires a little bit of input, and some of it you can you can get it by guessing. So in one form of GrabCut, you scribble, right? You can say that, okay, this is the foreground. You can scribble using one color, right? And you could say that this is the background. And you could have a third kind of scribble, which says, I don't know. So on the boundaries, you would have a third kind of scribble. You would say, don't know. On the object, you would say that I know definitely, right? And on outside it, you would say that, okay, this is definitely background, okay? Using those three masks, you can create this kind of very neat mask, right? And but there are other modes of operation also. We have used a second mode of operation for GrabCut, where you basically provide a bounding box, and it does the cutting. The bounding box says that inside this box is the object that I want to segment, right? And outside this box, we have object, the object, all the things outside this box or on the box, they are part of the background, right? So we basically take, in our code, we take a bounding box, which is 20 pixels inside, and we say that all of it is inside, right? And anything outside is part of the background, and anything inside is part of the foreground. And that information is also sufficient for it to recover this, right? So GrabCut is basically an interactive segmentation technique, and we have made it non-interactive. We have made it automatic by using this heuristic, right? The heuristic is that we know that this document is not going outside the image. If it does, then the technique will fail, right? So now you can see when we use GrabCut, the way to use GrabCut, you can see the functionality here, right? You send in the image. You can, we have created a mask. We are going to create a mask where the 20 pixels boundary, right? It will be part of the background, and the rest will be part of the foreground, right? And that is enough. So you can either provide a mask, or you could give a rectangle, right? Which is a bounding box that I mentioned. And then you have to pass in these things, which BG model and FG model. If you have this model, that is great, but usually it will calculate these models by itself. It will create these models by itself. You don't have to supply it. And then it is an iterative process, right? GrabCut works over many iterations. So you have to say how many iterations do you want for this GrabCut method to use. And this kind of thing you figure out by trial and error for your application, how many iterations are useful, right? For some applications where the background is simple and the foreground is simple, you may be able to get up, just a couple of iterations is enough. Sometimes you need more iterations because it's more complicated. The model that it is building, it takes more iterations to build the foreground and background model. And in those cases, you would use more iterations, okay? So here, if you look at the code, we have created a mask of all zeros. The background and foreground model is also all zeros. And don't worry about this exact model, right? because we are not going to supply it, and it's not trivial to supply this as well, but we don't need it. The rectangle, right? We are saying that, okay, it is a rectangle which is 20 pixels in from all sides. So it's a rectangle which is the same aspect ratio as the original, not the same aspect ratio as the original image. It is just 20 pixels in from all sides, right? So that's the rectangle. And then we are passing it to GrabCut, and GrabCut is going to populate, right? It is going to make this mask. So GrabCut is going to populate this mask, and the value, right, of this mask would say where our current mask is, right? We initially said all the mask values are 0, but when we call GrabCut, it is going to populate mask with all these values, right? So here it says basically the mask, if the mask value is 2, which is the foreground, or the mask value is 0, which is unknown, then we say that that's the mask, right? So if you put in this image, okay, sorry. So if you took the original image, right, this was the original image, and we applied GrabCut to it, the rectangle was the one that I mentioned, you will get an image like this, right? And here, while displaying, we have multiplied the image with the mask, so that you're not just looking at the mask, but you're looking at the image multiplied with the mask, all right? So the next step, right, when we is, okay, we have this cleaner image. See, we started with this image, which was pretty cluttered, right? There were all these lights, etc. And then we used morphological operations to clean it up and make the next steps easier. Then we use GrabCut to create this kind of a mask. So in that document, if we remove this, if we change this code to only show the mask, if you don't multiply it, then you will see a clean mask like this, right? It is a binary mask that you will see. Now, okay, so we have segmented out the part that we are interested in using GrabCut, right? Next, we are going to use edge detection and contour detection. And this is a utility that is very, very handy in OpenCV, right? This contour detection, it's not easy to implement. You will spend a lot of time if you try doing it yourself. And these kinds of utilities are so useful because you could do a lot of things with deep learning, but then the cleanup part, right? The little things, the post-processing that you need to do to get an application from end to end, they are often done using standard computer vision techniques, right? So a lot of people may be already familiar with canny edge detection. This was, it's a funny edge detector because canny basically, there were a lot of edge detectors at that time. This is, I think, around 1994, where a lot of edge detectors had come to the market, but canny basically very cleverly took all the good ideas and put them into one detector. And after canny edge detector, there have been other edge detectors, but this has stayed. This technology is 1984 of the 1980s, and it is still used today as the default edge detector, right? And the improvements upon it, right? The improvements upon canny edge detection are all learning based, which means that it's not a general purpose edge detector. Sometimes for your particular application, the edges that you determine have very specific meaning, right? For example, you may be, let's say you're doing, this is the first time I actually, when I was in grad school, I learned about learnable edge detectors. One of my lab mates, she was tracking mice, right, in a lab condition. And she did not want to be distracted by all these, the other edges. She wanted to find only the contours of mice, right? And for that, she trained an edge detector that fired only on the contours of the mice and not anything else. And then it became easy for her to do subsequent tasks. So, canny edge detection is a non-learned edge detector, right? It doesn't use any images to learn the parameters, right? You just give some parameters and it outputs the result. But there are edge detectors which are based on machine learning, right? You can train the edge detectors. All right, so I went on a side note. So canny edge detection is, like I said, that it used many different ideas that were in that in many different papers, and it put it together. One of the ideas was hysteresis thresholding, right? So you have an image. The way standard edge detection is done is that you have an image, you calculate the gradient of an image, right? And people who know gradient, you can think about gradient. The X gradient of an image is that you take 2 pixels side by side and subtract them and put the value of the gradient right there, right? So basically, just like differentiation in 1 dimension is taking differences, in 2 dimensions, gradient in the X direction is taking differences, right, of subsequent columns, and in the Y direction, it is the difference between subsequent rows. That's there is somewhat more sophistication to gradient calculation, but that's essentially it. So once you calculate the gradient, right, you can simply choose. You can create a threshold and say that edges are places where the gradient is high, right, where the image intensities are transitioning quickly. That's where the edges are, right? You can think about a binary image where you have a white thing on a black background, and at the boundary where the edge is, the intensities would transition quickly, which means that the gradient would be high, right? Which is fine, right? That is why we have a threshold. Now, the second threshold is necessary, right? We have 2 thresholds in canny edge detection, and this kind of 2 threshold thing is called hysteresis thresholding. What happens is, when you're doing a single threshold, the first threshold is low, which means that the first threshold is high, which means that you want the gradient to be high when you start the edge, but then the edges could start fading away, right? Because of imaging, because of several reasons. And then you use a lower threshold to threshold the edge. If it is if the edge is continuous, if it is attached to some other edge pixel, then you use a lower threshold, right? By using this hysteresis thresholding, where you have a high threshold and then a low threshold, you can maintain the continuity of the edge. Otherwise, you will see these, the edge would not be continuous because, if it is above the threshold, you're using something else, and below the threshold, you're using something else. So the edges may break into smaller pieces. You don't want that. By using hysteresis thresholding, that once we have determined that we are following an edge, then we will lower the threshold of that gradient so that the edge can continue even if it is fading a little bit, right? I hope I'm able to, that went through.
Makes sense to me.
All right, that's great. So now we are doing edge detection, right? Usually before doing edge detection, you do Gaussian blurring, right? Canny edge detection itself, many implementations have a built-in blur, but it's a good idea to blur it yourself because you know exactly what your problem is, so you may be able to figure out what should be the blur kernel, how much you should blur, etc. The reason you always blur before doing edge detection is edge detection is based on gradients, right? Whenever you calculate the gradient, and gradient is differences, right? So when you take differences of things, right, the noise in the estimate of that difference can be very high because differences are small numbers. Imagine, right? You have a pixel that is 255. The pixel next to it could be 254 or 253, right? And that 1 pixel intensity difference makes a big difference. The difference itself, the estimate of the difference itself could be off by 50% based on whether it is 254 or 253, right? So whenever we take differences of things, whenever we take gradients, etc., the estimates can be very noisy if you don't do smoothing of the image. If you smooth the image, then these pixels, right, they smooth out. So they will gradually change from 255 to 254 to 253 and 252, etc. When you smooth the image. So whenever you want to take a gradient, you smooth the image, right? And that is what we are doing here. So so you do a Gaussian blur and you do edge detection. And just for, for display purposes, we have dilated the image. the canny edge detector has been dilated so that you can see this image. Otherwise, it is, really, it's really tiny and you cannot see it properly, right? This 1 pixel image. So, so now you can see that canny edge detection shows you this, this result. Now, one of the reasons we did the dilation in the beginning is also because, once we did canny edge detection, we didn't want edges from inside to interfere with our estimates, right? We want to get only the boundary ones. And so we wanted to remove everything inside inside this document. Okay, so now the next thing is contour detection. This is such a useful functionality in OpenCV. Whenever you're working with contours, this has all the tools you need for doing contour detection, finding contours, estimating the contours, etc. So here, find contour. It's a monster of a of a function. So it's difficult to explain what are the different modes of this. But basically, you can detect contours, right? And you can say that, okay, my contour should be an approximate polygon, right? You could also say that, okay, my contour, there could be 2 contours, one inside the other, right? Things like that. So study this, find contours, and you will see how powerful it is when you start using it. And we are going to use, in find contour, we are going to use the reason we are doing find contour is we just have retrieved the edge pixels, right? And you can see that the edges are not perfect, right? And these are just pixels. We don't know the connectivity of these pixels. So we want to find something which will create a contour out of it. We will know that, okay, these pixels are connected in a certain way. And we also want to approximate whatever pixels we have estimated, we have found. We want to approximate the shape with a quadrilateral, right? Because we know that it's a polygon with 4 sides, right? We want to approximate this with a polygon of 4 sides because we know that it is a paper. And when you take a picture of a paper or any sheet, it will remain a quadrilateral, right? It may not be a rectangle anymore, right? It may not be, it will not be a parallelogram. It will be a convex quadrilateral, right? Which means that the angles are not going to be changing. There will not be an inside dip like that. So, so we are going to use find contours for that purpose. And you also have this draw contours function, which helps you in drawing this contour. Very, unfortunately, I'm not able to go into the details of find contour as we do in our courses because of time constraints. But this is one of very, very important, very, very useful functions in OpenCV that you can do when you're doing binary image analysis. Okay. So here, let's see how we use find contour, right? So we have this contour that we fill with the image, right? It is the same size as the image, but it is filled with zeros. And then we do find contours. The contours, it finds the contour as well as the hierarchy, right? We don't have to worry about the hierarchy, but you still have to you still have to give it in your function. Now we are sending in the canny edges to find contours, right? And we are going to retrieve it as a list. And we are saying that there are many different contour. Like I said, that OpenCV is composed of 2,500 different algorithms built into it. So things that look too easy, right? Behind every of these parameters is a different algorithm, right? So we are using a particular algorithm called chain approx. So we are not using this approximation that you could. We are using, we are just saying that, don't use any approximation, right? But there are several options that you can look at, study, and see which one works for you, okay? So once we have found the contours, right, there could be other noisy things also, right? And we don't want those noisy things, right? We just want the biggest contour possible. So we are sorting the contour based on the area of the contour. Again, there are so many different applications of of this thing that we can use the area of the contour to figure out, okay, which is the biggest contour. There could have been other noisy things in this, right? Which smaller contours, they would go away and we will only get the biggest contour. And now finally we are drawing that contour, right? Next, we want to find an approximate rectangle. So we found the contour, but now we want to find an quadrilateral from this contour that we extracted. So here we are, So we did contour detection and we want to find this quadrilateral, right? We can still see here that the quadrilateral, this is still a contour. It is not a quadrilateral yet. So first, we are going to use two functions for it. One is to find arc length. So the length of the contour you can simply find by using this function in OpenCV called arc length. And it will give you the length. And if it is an open contour, right, we cannot guarantee always that this edge detection worked perfectly. Sometimes there may be gaps in this contour. And when we say closed, it will close the last point with the first point. It will combine it, right? So we are making sure that this arc length is on the closed contour. And then we are going to use an approximation, right? We are going to use this thing called approx poly dp, right? Which basically takes this contour and it will need this parameter called epsilon, which says that how far can the polygon be? We want to find a polygon which basically this contour basically represents a polygon in which, in our case, it's a quadrilateral, and we want to find that quadrilateral, right? But we also need to specify how far are you allowed, right? What is the error you are ready to tolerate? And that we need to specify, okay, we need the tolerance up to this epsilon, right? And then we say that it is, a closed curve and, it's an approximate curve and so on and so forth. So here's, here's the implementation of the quadrilateral, of the contour thing. Let me check what is, okay. Let's go to this one first and then we'll come back. So here we, again, we create con equals, basically it's a mask which is it's an image which is filled with zeros and it has the same shape as our original image. And then we get the approximate length of the entire contour. And we say that our epsilon should be within 2% of the length of the curve, right? So when we are calculating the polygon from this contour, we want to make sure that the polygon is within 2%, right? Otherwise, it should throw an error, right? Then we know that we are not looking at the right thing. So we get the corners of this contour, right? And we are saying that, okay, we want to approximate this contour with this error, right? And if we then check whether this is an approximate polygon, right? We want to make sure, a quadrilateral. We want to make sure that the polygon that we have retrieved, it's a quadrilateral. If it is not, then we'll have to give up and do something else, right? But as it happens in all tutorials, this will work, right? For the data that I've given you.
Of course.
So then we come and basically draw the contour, right? And we draw the points. So these corner points are sorted in a way so that we can go over them in a circular way. And then we display these corner points. You can see that after we do this, we are essentially getting these 4 points, right? Which form the quadrilateral, right? Which this contour represents. You can also see that little loop is gone, right? Initially, we had this little loop because this might have been a different contour, right? This might have been a different contour. And because we are looking for only the largest contour, that little detail is gone there, right? And we get these points out. So Okay, so now we are good. We are at this stage where from the contour we have been able to find what the corner points are. Okay, and then we still need to do a perspective transform, right? We need to do a perspective transform which takes this image and transforms it into this image, right? And that is done using something called homography. So there is this transformation which says that when you take a camera, any camera, and you're taking a picture of a plane, okay? And let's say it is like the sheet of paper on the ground, right, which is a plane. Now you move the camera and take another picture. These two pictures, or all the points on this plane in one camera are related by a transformation called homography with the other image. And if you have 4 points, you can estimate this homography. If you have more than 4 points, corresponding points, right? If you have more than 4 corresponding points, in that case, you can basically use something called least squares estimate, right? Or you can use something called ransack estimate, which robustly calculates the homography between the two images, right? So all you have to remember right now is that the two images, the one, if you have a plane and you take 2 images of the plane, they are related by a homography. And this homography is, it's represented as a 3x3 matrix inside OpenCV, but actually it has 8 parameters, right? And you just need to, once you estimate that homography, you can apply it to the entire image and it gets transformed, right, into the right aspect ratio. So find homography, basically it takes corresponding points, right? So we need source points and destination points. Source points in our case are the 4 points of the quadrilateral, and destination points are the 4 points of our final image, right? As I said, that we know the aspect ratio of the final image of the paper, right? So it could be 8:10 or whatever is the standard letter size, 8.5 by 11, whatever it is. I cannot even remember that. So whatever aspect ratio
correct.
is, right? So, and you basically you could say that, okay, I'll have an image which is 850 pixels across, and the height of the image is let's say 1100. And any image that I get, I'm going to transform it into this. So your 4 points will be the 4 corners of this transformed image. And there are several methods for calculating, this homography. They don't matter because in this case, because they matter when you have more than 4 points. 4 points are the absolute minimum you need to for calculating a homography. But when you have more than 4 points, then there are intelligent ways to make it robust. And most of the time, you should be using ransack. It works really well. But there are other methods also, right, when you have more than 4 points. But in this case, it doesn't matter much. And once you calculate the homography, you can simply pass it. You can pass in the original image and this homography matrix, and that will do the transformation for you, right? So you can see that we started with this, right? We get the perspective transform. We get the homography by sending in the corners, the destination corners and the source corners, or the source corners and the destination corners. And then we simply use the homography that we got, and we warp the original image using that homography. And you get the final image, and you can get something like this, right? So that's the computer vision way of doing it. And we are exactly at 9:59. Which is great because we have pretty much covered everything, right? And I'll go over a few more things in just a bit. Now, there are some limitations of this approach that we said, right? So these results would work great, right? If you use this kind of results, right? But if you have white on white, right, or things like this, then this computer vision approach is not going to work, right? It is going to basically, in this case, for example, it is going to blur out everything. And that is where learning a learning-based approach is useful. And that is what we will cover in our next course or next webinar on September 26th, right? It's another limitation of this approach is that if you are partially occluded, then you will not be able to recover this from this as well, right? Because it's basically not, it will find that, okay, the contour is not a rectangle and you won't be able to do it. So we will cover this thing in, on September 26th, the deep learning based automatic document scanner. I also wanted to inform you about this AI career webinar. And if you can sign up for this webinar, it's a recorded webinar, right? It is, but there is somebody on, usually there is somebody manning that recording, which means that if you ask a question, you will get an answer. So sign up for opencv.org/3 secrets to an AI career. And I'm going to copy this link. Oops.
Yeah, we'll put it in the show notes as well for folks out there watching on YouTube.
Yep. So you can go there and look at. So this is a long webinar, so keep at least 1.5 hours for this. We go over all the breadth of what are the opportunities available, how are students doing, and things like that. So, for example, one of our students, Antonio Luna, he is from Mexico, and he was a freelancer, and because of ChatGPT and other things, right, there was a lot of pressure on his hourly rate on Upwork. So he's on Upwork, but he was a developer and he saw a lot of pressure. In fact, his hourly rate reduced by 50% after ChatGPT came along, right? So he enrolled in OpenCV University program, and took him a few months, but now he's able to charge 2 to 3 times more than what he was able to charge before, because now he's a computer vision expert, right? And this kind of thing can happen to you as well, right? If you are ready to commit time and energy into the program. Here's another example, Andy Gallen. Andy says, the computer vision course offered by OpenCV University played a crucial role in starting my AI career. I landed a 6-figure consulting job in AI right after I graduated. A year later, I was hired at Tesla as a data engineer with double the compensation. $200,000 after 2 years of taking our courses. That's just amazing, right?
Not bad at all.
So OpenCV University was the best investment in my AI career, right? And this is what a timeline looks like, right? Andy started as a mechanical engineer. He switched to AI because he wanted to have a remote job. And in June 2020, he joined OpenCV University. In just a few months, he had gained so many capabilities that he was able to be in the top 25 of OpenCV AI competition. He actually built a car that could drive itself in a parking lot and follow a person, right? Which is great for like a 3-4 month project. And he was in the top 25. He attributes a lot of the success to OpenCV University course. And then he got a job, early in 2021, just a few months later, he got a job as a consultant, 100K plus a job. And then finally, he got a job at Tesla in 2022, about a year later, right, with double the compensation. So you can see that people are able to transform their careers by following our program. And you just have to be dedicated. It's not rocket science, right? And the good news is that AI is everywhere.
I mean, it may be rocket science depending on where you get a job.
Whether it's deployed on a rocket or not. That is right. So for this kind of material, we have 2 courses. One is Mastering OpenCV with Python. And here are a few different applications from that course. This is sort of a starter course. You get a wide, you get to know the breadth of computer vision techniques that are available in OpenCV, and we build several applications. All our courses are very applications oriented, and we build several applications using in this course. You can see some of them, like a golf shot analysis, and then we have what is it called? Social distancing, lane detection, object tracking. And then we have a second course, Fundamentals of Image Processing and Computer Vision. This is basically a foundation course in computer vision. This is one of our flagship courses where we teach everything about computer vision, starting with the very basics: image thresholding, color science, high dynamic range imaging, image alignment. This homography thing is also covered in that course, and feature tracking, etc. So it is loaded with all the knowledge you need in any, most computer vision jobs for traditional computer vision. We also have deep learning courses, but the material that I covered today, that is mostly in these two courses, right? When you sign up for our program, you also automatically enroll in Career X. Career X is basically a program where we help you in the last mile, right? So we have prepared you with 7 or 8 months to face a job interview, or to be, you've already become an AI expert when you enroll in this program, but you don't know the last mile, right? Sometimes, even if you're an expert, you may not have all the tools ready to face a job interview, because getting a job is different from doing a job, right? So we give you personalized guidance. We have a LinkedIn program where we help you improve your LinkedIn profile. We have a GitHub program where we help you improve your GitHub profile, show your work on GitHub, show your resume as a GitHub page, and also guide you what kinds of projects would be useful. By the way, all our courses are loaded with very interesting projects, because our fundamental belief is that today nobody cares about your degrees. Nobody cares how much what your resume says. What you demonstrate on your GitHub profile, right? The applications you have built, what real world problems you have solved, that counts much more than your resume. But we also help you improve your resume. And finally, we give you job assistance, right? It's not a job guarantee program, but it's a job assistance program where we'll do mock tests, mock interviews, etc. for students who qualify, right? You have to do well in our courses to qualify for this mock interviews and mock tests. And then you're assigned a student success manager to help you out, okay? Finally, the whole program consists of many courses: Python for beginners, Mastering OpenCV with Python, Fundamentals of Computer Vision and Image Processing. This is a Python-based course, and this is the foundation of all traditional computer vision techniques. Deep Learning with PyTorch and Deep Learning with TensorFlow and Keras. These are foundational courses in deep learning. And then we have an applications called Computer Vision and Deep Learning Applications. Even though all our courses are based on applications, you build a ton of projects, and if you choose to publish your work on GitHub, it will just look loaded with very interesting projects, right? And then we have short courses in generative AI. They are a series of 2 courses under Mastering Generative AI for Art. And then we have Deep Learning with Python book is also included in this. When you join this program, that book is given to you for free. And even if you decide to not pursue, you get to keep that book. That's a 30-day, no questions asked, money-back guarantee, which is better than a money-back guarantee, because once you take this program, and if you don't like it for any reason, you get your money back, but you also get to keep this book by Francois Chollet, and you can just keep it. And then we have Fundamentals of Computer Vision and Image Processing. The C++ version is also included in this program. And finally, everybody who qualifies, right, they have to do well in 2 courses. One, Fundamentals of Computer Vision and Image Processing, and the second course is Deep Learning with PyTorch, or Deep Learning with TensorFlow and Keras. So one deep learning course and one computer vision course. Once you have completed with good grades, you qualify for Career X, and we will help you. It's in our best interest to show that, okay, our students are getting good jobs, but it also helps you a lot, right? Because that last mile, a lot of people, engineers especially, right? We are not very good at selling ourselves, right? We are not very good at showing what we know, right? So this Career X program really helps people who are really good, but they tend to not demonstrate how good they are, right? In job interviews, they don't interview well for one reason or the other.
It's a different skill. It's a different skill that you have to exercise.
It's really sad to some extent, but it is true, right? So
you show a little bit of personality and a little bit of it can't just be the code, because
Right.
Lots of people can write code, but only you can write your code, right? Only you
Right.
can
Or
do stuff the
ChatGPT
way
can
you
write
do
your
it.
code.
Yeah, exactly. And in many cases these days,
Right.
yeah.
So it's funny. I was trying out Cursor, and in fact, for this presentation, and when I was trying out, it was producing, even the variable names were from learnopencv.com. It was
I
very
was going to
similar
say,
to.
like, how often do you recognize your own code?
You're still able to see my screen, right? Let me see if I
Yes, definitely we can.
close it. Did I close it? Oh, I closed it. I don't know. Let's see. Oh,
I
yeah.
saw
Yeah.
this. So for folks that don't know, Cursor is this newer code editor. They actually bought cursor.com, so they've got some kind of VC money going on.
So do you see this? Do you
Yes,
recognize this code that I showed?
I see this.
So this was auto-generated by
This
Cursor.
is just from the demo today.
This is from the demo today, and they have added these comments and stuff, right, which we did not
Mhm.
have. But look at this, right? It looks
Wow.
exactly like our code. Look at this
Yeah.
also, right?
Yeah.
So anyways.
What's it feel like to plagiarize yourself?
It's fun.
Odd times we
Odd
live in.
times, right?
Interesting times, as the old curse says.
But I think we should do a session later on, later in the year, about using these AI tools to write.
Yeah, sure.
Because they're
Like
here to stay. You cannot do anything about it. As much as I hate that this stuff was plagiarized,
Yeah.
but there is a kind of satisfaction also that it is now reaching more people than it would have if people had come to our website. As such,
True.
people can use whatever they want to do with the website code. So yeah, so there is that bittersweet satisfaction. If they actually gave a reference, right, that this was taken
Yeah.
from us, I would love it.
Why wouldn't it be? It's knowable, right? It's like, there's a lot that could be done. It just these companies seem to lack the will to do that.
Yeah.
And maybe through bullying them, we can make them do the right thing. That's what the internet's for, folks. Speaking of what the internet is for, right now we're going to do a giveaway to you in the audience. One of the things we do on this show is a special giveaway of one free OpenCV course of the winner's choosing to a lucky viewer in the OpenCV audience here on Zoom. Today, I'm going to ask a question based on the presentation from Dr. Satya Mallick, and the first person to answer it will win that course. You can go to opencv.org/university to see what courses are available. And if you have won recently, please do not answer and give someone else a chance to win. All you got to do is type your answer in the little Zoom chat window on your screen right here. I have a feeling this one's going to be an easy one for y'all. So earlier on the show, we talked about GrabCut, which is an algorithm implemented in OpenCV 2.1. What corporation patented GrabCut? Bam.
Oh, that was
Got it.
that was a softball.
Bojan, please send. You just like right on it on that one. Please send. The answer we're looking for was Microsoft. Please send one email, Bojan, to phil@opencv.org. But first, go to opencv.org/university. Pick the course you want. Send me one email with the name of the course, and we will get you that course right away. Yes, congrats. I know.
So,
every time I say something early in the show, people just like write it down now because they figure I'm priming them for the answer. So I tried to not.
These
I
are the
tried to
various
specifically.
answers.
Yes, I tried to not say it this time, and so yeah, we got 1, 2, 3, 4, 5, 6, 7. 7 folks got it right, but the first one was Bojan. So send one email to Phil.
It's funny
Satya,
because that group at Microsoft was so influential when I was in grad school. They pretty much had the best, the book Computer Vision is written by Richard Zaleski, who was the head of Microsoft research at that time. And I have a personal story. I was actually going to intern at Microsoft, and this was like my dream come true, right? This is like, oh, this is the best thing that can happen to a grad student, getting to work with Richard Zaleski and Singbing Kang, right? There are these two great people at Microsoft Research. And then I got a little money from UCSD they have an entrepreneurial center, and I really wanted to do my startup. And so I went and refused this internship 7 days before joining. It was so embarrassing, but they understood that, okay, I was going to do my company. And then, I fortunately got funding. And as a grad student, I could not have survived without any funding. And that funding came through from the Von Liebig Center at UCSD. And that enabled me to start my first startup. So
See, nowadays it's more the opposite, where you hear stories about the company makes you an offer and you accept it and you get ready to start, and then 2 days before the start they rescind it. And I'm like, that's not really how that works.
All right.
Like I think you would, like, every time I hear this about any company, I mean, Tesla, like, it just makes me like them less and less. Like it seems it's such a bizarre way to behave. Like what manager, like, how could you're a failure at your job if you have to do that, right? Like you have one job and you failed at it. Anyway, if you have any stories of recent stories of awful job interview experiences, please send them to me. Send them to newsletter@opencv.org.
Publish in our newsletter.
You're not the only one. If you would like to, if you have some interesting stories, we will anonymize them. So we want to put you on blast. But if you'd like to tell some tales, please send us an email to phil@opencv, and maybe we'll publish some in the newsletter as part of our content about OpenCV University. Maybe make your own stuff, learn some from OpenCV U. Speaking of learning your own stuff, we've got, I think now's a good time to take them home. Doc, you wanna parallel park this episode?
Yes. Thank you so much for joining and, staying through the webinar. And we are going to do more. If you would like us to do more of these, just send us an email. The more emails we get, we will know that, okay, these are the kinds of episodes people like, and we are going to do more of these. So we are going to do at least one more, on September 26th. And please tune in then. And thank you so much. Thank you, Phil, for organizing this show.
You are welcome, Satya, and all the folks out there. Again, if you need to contact us for any reason here, please send one email to newsletter@opencv.org or phil@opencv.org. You will be able to find the recording of this episode on our YouTube channel at youtube.com/@opencvofficial. And I think, Satya, are you cool with posting the PowerPoint slides here, or the Google presentation slides? A few folks asked about it, so we'll add the presentation slides to the YouTube show notes as well. And if you have any other questions about this episode, send them to the email address newsletter@opencv.org, and we'll shoot you a reply for that. Join us next week, as we'll be joined again by our illustrious multi-time guest, Joseph Nelson of RoboFlow. And then the week after that, we've got, what else do we have coming up here? Yeah, Joseph Nelson of RoboFlow on the 19th. We've got nothing booked yet, possibly a student showcase. Anyway, if you're a student out there and you've got a small project, maybe a 15-minute presentation project, send an email to phil@opencv.org, and maybe we'll have you on an episode of the student showcase at OpenCV Live. That being said, take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. We'll catch you next time.